We'll move on to question 2. In this one here, we have a round disc. So it has a radius of 0.35 meters. It rotates at a constant radial speed of 200 revolutions per minute. What is the linear speed at the outer edge of the disc? Okay. Okay, so radial disc, 0.35 meters, 200 revs per minute, and it wants to know if there was a spot on this disc, let's say right here at the top. What is the linear speed? So what is the meters per second of the edge of the disc? All right, so we have a correlation between linear speed and radial speed, and we know, excuse me, we can get to, actually here we should do it this way. We should get to linear speed through angular speed or radial speed by means of the radius. Okay, so if, actually I don't need to get into that. We're solving for this for v. So we're going to try and solve for v linear speed using radius in this. We have the radius, that's easy enough, 0.35. The omega is the tougher part, which is why I wrote that out. Omega needs to be in radians per second in order to get this into meters per second. So we're going to need to have omega in radians per second. And right now, we're at 200 revolutions for every 1 minute. Okay, that's not going to work because we want it in radians per second. So we're going to have to do a conversion. Revolutions I want on the bottom. And the conversion factor that I know is that 1 revolution is the same as 2 pi radians. Okay, that'll get rid of revolutions. And then we'll also have minutes here. We'll have to put minute up top, and I want this to be in seconds down below. And I know that there is 60 seconds in every minute, so we can cancel that out. And that will get us into our radians per second. Okay. Excuse me. Now if we do that out, we have 200 times 2 times pi. And they're going to divide the whole thing by 60. We get an omega of 20.94. So now if we're solving for v, we have v then would be equal to rw, which would then be equal to 0.35 multiplied by our w, 20.94. Okay, and if we do that, looks like we get a linear speed of 7.33 meters per second. And that's our answer for part A. That's the linear speed of the outer disk. Part B, what is the linear acceleration at the outer edge of the disk? Okay. Okay, for that one, it says that it's rotating at a constant radial speed. Okay, so we know that there isn't any radial acceleration, but there is a linear acceleration taking place. Linear acceleration that is taking place is going to be the centripetal acceleration. Okay, so AC, centripetal acceleration, which we know to be v squared over r. Okay, so we did this one in class. V squared, now we know what v is on the outer edge of the disk, 7.33. That will get squared, and then we'll divide that by that radius, 0.35. Okay, so we'll do that. We'll square our answer and then divide by 0.35, and we get an answer of 153.5 meters per second squared. Okay, so that will be the centripetal acceleration of the disk, 153.5. And the last question on here, part C, asks, well, which direction does this point? And you have multiple choices for that. The direction of centripetal force, centripetal translates to center seeking, so it is always towards center of disk, or towards the center of the circle that is making it. Okay? Towards the center seeking.